Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about factoring quadratic expressions.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, x squared minus 7x minus 18, and we have to factor this completely. We first are looking at our a value, which we know is 1. So then we just have to look now at the c value, which is 18, or negative 18. So I'm going to take 18, and I'll find the factors of that. What two numbers multiply to be 18? Well, 1 and 18, 2 and 9, and 3 and 6. Now they tell us this is a negative 18. Okay, so it's a negative 18, so one of these numbers will have to be negative. We're going to see what two numbers multiply to be this c value. Okay, so that's what we found here. And then we see which ones add to be negative 7. So if one of them is negative, okay, one of these is negative, which two combinations, when we add them, gives us a negative 7. And I'm looking at my 2 and my 9. Negative 9 plus 2 equals a negative 7. All right, so with that information, this is actually pretty simple to break down. We have our x here, our form. We have x times x. The two numbers that add to be negative 18 but add to be a negative 7 are negative 9 and positive 2. So we put a minus 9 here, a plus 2, and that is it. That is our final answer, x minus 9 times x plus 2. We're given this problem right here, p squared minus 5p minus 14, and we have to factor this completely. I look at my a value, it's 1, so it's pretty standard here. With that, I look at my c value, which is a negative 14. So I have to ask myself, what two numbers multiply to be a negative 14? And I really just focus on the positive 14, so it's like 1 and 14, and, well, 2 and 7. But since it's a negative 14, I know one of these numbers will have to be negative of a pair. Now I have to ask myself the second question. What two numbers add here with some combination, one of them being negative, to be a negative 5? Okay? And that is actually with 2 and 7. 2 plus a negative 7 equals a negative 5. And so those are the numbers that I'm looking for here. So I'm going to set this up in my standard factored form with the p's here on the end, be multiplied. And then I have to use my combination here. I have a positive 2 and a minus 7, and we've actually factored this. All right, our final factored answer now is just p plus 2 times p minus 7. We're given this expression right here, m squared minus 9m plus 8, and we need to factor this completely. My a value here is just 1, so it's good to note. That makes it simpler. And then our c value here is 8. So I'm going to take that 8 value and I'm going to find, well, what two numbers multiply to be 8? And that's just 1 and 8, and, well, 2 and 4. But they also tell us that our b value is negative, meaning that both of these numbers will have to be negative. All right? So what two numbers now together add to be a negative 9? And that's going to be the negative 1 and a negative 8. Negative 1 plus a negative 8 equals a negative 9, our b value. So we use those numbers to get really our answer here. We write this in our factored form. And here we put, well, just the minus the 1, I almost put a 2, minus the 1 and minus the 8. And so our final answer here is just m minus 1 times m minus 8. We're given this problem right here, x squared minus 16x plus 63, and we need to factor this completely. My a value is 1, which makes this problem a little easier. I only have to look at really my c value now. My c value being 63. So now I need to write all the multiples, two numbers that multiply to be 63. And that's 1 and 63, 3 and 21, and 7 and 9. So now I look at my b value. It's a negative 16. So that gives me the clue that both of these numbers here, being multiplied, have to be negative to get us that positive 63. Now I'm asking myself, what two numbers, when added together, equal a negative 16? And that's actually negative 7 and negative 9. Negative 9 plus a negative 7 equals a negative 16. So with that information, we can factor this. We have our basic factored form here. We have x and x here. And we put our two numbers, -9 here and -7. And so our final answer here is just x minus 9 times x minus 7. We're given this problem right here, 7x squared minus 31x minus 20, and we have to factor this completely. Well, we notice our a value being a 7, prime number here. So that's going to be a little thing we're going to keep in our head. We now also look at our c value, a -20. So I'm going to put a positive 20 here, and I'm just going to write the two numbers that, well, multiply to be 20. That's 1 and 20, 2 and 10, and 4 and 5. Now, they say it's a -20. And since it's a -20, we know that one of these numbers will have to be negative. We don't know which one, but one of the pairs will have to be negative. Now, back to that a value being 7. Well, being prime, we know we have the form of this. We know our factored form has to be 7x in the beginning of the first parenthesis and x in the beginning of the second parenthesis. So now I have to ask myself this question. 7 times which one of these numbers plus the other number gets us our b value, which is -31. It's kind of a tough question. And remember, one of them has to be negative. Well, I'm going to give you a clue. The pair here, when doing that, is the 4 and 5. If we have 7 and we multiply it by a -5, we get a -35. And a lot of times I look for numbers that are kind of close to that b value. -35 is close to -31. I then take that -35, and if I add the other value, the 4 to it, I get that -31. That's the b value that I was looking at. So how do we write our order here? Well, we know 7 has to be multiplied by the -5. So the -5 actually has to go in the second parenthesis. And then its pair, the +4, right here, goes right there. And so our factored final answer is just 7x plus 4 times x minus 5. We're given this problem right here, 7k squared plus 9k, and we have to factor this completely. Now this is an interesting problem here. Notice we only have an a value, a b value, and our c value is not written, meaning it's 0. When that happens, we actually have a pretty easy way to factor this. I see a k in the first and second term. If I pull out that k, what am I left with? Well, 7, and then k squared divided by k is 1k, and then 9k divided by k is just a 9. I then look and say, okay, is there a common term in our factor in 7 and 9? No, nothing, they don't share anything. And so actually, we're done here. At this point, our final answer is just k times 7k plus 9. We're given this problem right here, 7x squared minus 45x minus 28, and we need to factor this completely. I notice my a value. My a value is a prime number, 7. So we know this is going to be in some form of 7x, and then an x like this. So let's keep that in mind. Now let's look at the -28. What two numbers multiply to be a positive 28? Well, that's 1 and 28, 2 and 14, and 4 and 7. So now with this information, I have to also look at the b value. B value is negative and the c value is negative. So that really tells me here that one of these numbers will have to be negative. Okay? And then when we add it together, we'll have a negative number. So now, tricky part, go back to the a value. We have to ask ourselves, a times which one of these numbers plus the other number gets us a -45. Okay? Now chances are, because 7 is a larger number being multiplied, that some of the numbers in the right-hand column will be a -1. That's what we're kind of thinking of because we want to get something close to -45. Okay? And so my first gut reaction is, well, dealing with this 4 and 7 here. Because 7 times 7 is 49, which is close to that -45. So if 7 times a -7, so if I make that one negative, that equals a -49. I take that -49, and I add the other number, 4, we get a -45, the b value that we're looking for. So the pair here has a negative on that 7 here. And so we want to make sure it's on this side where this 7 would multiply by this one. So we put a minus 7 here. We put a positive 4 here. And now we've actually factored this. Our final answer is 7x plus 4 times x minus 7. We're given this problem right here. 2b squared plus 17b plus 21, and we need to factor this completely. The a value being 2, a prime number, lets us know that this has to be in some form of 2b in parentheses then times 1b here. And we have to really fill in the rest of the factored form. So now look at 21. I want to find, well, the c value, sorry, 21. Find two numbers that multiply by 21 and list them all. And that's 1 and 21, and 3 and 7. So now I have to ask myself this. 2 times which one of these numbers plus the other one, other pair, gives us 17. And when I first test some of these out, I'm looking at 2 times which one gets me really close to 17, and that's going to be the 7. So my pair here is actually at 3 and 7, and we can see that here. 2 times 7 equals 14, then 14 plus the other number 3 equals 17. So we have our pair, we can go put them in right here. 2b has to be multiplied by the 7, so I put a 7 on this side, and the 3 goes on this side. And so my final answer in factored form is 2b plus 3 times b plus 7. We're given this problem right here. 5p squared minus p minus 18, and we want to factor this completely. Notice my a value is 5, a prime number. So we know this is going to be in some form of 5p in the first part, and the second part has just a 1p. I now look at my c value being negative 18. What two numbers multiply to be a positive 18? Well, that's 1 and 18, 2 and 9, and 3 and 6. Well, since it's a negative 18, I know that one of these numbers has to be negative, okay? And this is going to be the tricky part. One of the numbers is going to be negative. We don't know which one. And we look at our a value being 5, and so we have to ask ourselves, 5 times which one of these numbers plus the other number gives us a b value of negative 1. And the pair that actually we're going to deal with is this 2 and the 9. Now one of them will have to be negative. So 5, right, and then actually the negative is going to be the 2. So 5 times a negative 2, oops, that's a 9, negative 2 here, equals a negative 10. Negative 10 plus the other number, which is 9, equals a negative 1, which is the b value that we're looking for. Look at that 2, it's like a balloon 2. If you actually watch this video, put a comment down below that says balloon 2. Alright, so we have our two values, negative 2 and 9, so how do they fit here? Well, 5 has to be multiplied by the negative 2. So put the minus 2 here, then we put the plus 9 here. And so our final answer in factored form is just 5p plus 9 times p minus 2. We're given this problem right here. 28n to the 4th plus 16n to the 3rd minus 80n squared. And we need to factor this completely. Well, first thing I notice, 4 goes into 28, 16, and 80. And all parts actually have an n squared as well. So I'm going to pull that out, and I pull out a 4n squared from all parts, and we're left with a 7n squared plus 4n minus 20. Alright, so for right now, I'm going to ignore this 4n squared and deal with the other parts. So let's go rewrite this down here. And we know it has to be in some factored form. Well, our a value inside the parenthesis from here on out is 7, a prime number. So we know it has some form of 7n, and then this one is just an n here. So now I have to look at the negative 20. Then I write a positive 20 and write the list of the two numbers that multiply to be 20. 1 and 20, 2 and 10, and 4 and 5. Now, since it's a negative 20, one of these numbers will have to be negative. Let's keep that in mind, don't forget it. So now we have to ask ourselves a question. 7 times which one of these numbers, and it could be positive or negative, plus its other pair, positive or negative, equals positive 4, that b value. Okay? And, well, the pair that I'm looking at here is the 2 and the 10. 7, and it's going to be the negative 10. 7 times a positive 2 is 14. 14 plus the negative 10 equals a positive 4. And a lot of times it takes some trial and practice to get this down. So 2 and negative 10 are our two numbers. So let's make sure now 7n we said was going to be multiplied by the positive 2. So we put a plus 2 on this side. And then we have a minus 10 here. Goes there. And so now we have it actually in completely factored form. 4n squared times 7n minus 10 times n plus 2. We're given this problem right here. 3b to the third power minus 5b squared plus 2b. And we have to factor this completely. Well, notice here that there's a b in all three parts. So let's go pull that out quickly. Pull out a b, and we're left with a 3b squared minus 5b plus 2. So now from here, we need to deal with the inside part. We see our a value here in the inside part is a prime number. So we know this is going to have some form of 3b here times a 1b, like that. So now let's look at our c value. C value is, well, 2. So they ask us, we have to ask ourselves, what two numbers multiply to be 2? That's 1 and 2. Now, we know since our b value here is a negative number, that both of these numbers will have to be negative to get us that positive 2, but a negative b value. So now, here's the fun part. 3 times which one of these numbers plus the other one gets us a negative 5. Well, that's actually the first one. 3 times a negative 1 equals a negative 3, and then negative 3 plus a negative 2 equals a negative 5. So our two numbers are the negative 1 and negative 2, but the order is what we're really caring about. The 3 gets multiplied by the negative 1. So we put a minus 1 on this side, because that's what causes the 3 to be multiplied by the negative 1. Put a minus 2 here, and now we have our final answer. b times 3b minus 2 times b minus 1. We're given this problem right here. 7x squared minus 32x minus 60, and we want to factor this completely. My a value is a prime number, 7. So we know it's some form of 7x here times just a single x value. Now let's look at our c value, 60, or negative 60, but let's just deal with the positive 60 first. What two numbers multiply to be 60? And there's a lot of them. That's 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and lastly 6 and 10. So with it being a negative 60, one of these numbers will have to be negative. Okay, so we keep that in mind. That it's negative 60, so one of these pairs will be negative when we're asking our questions here. Now, we have to see 7 times which one of these plus the other one gets me negative 32. And the thing I'm looking at is trying to find, well, kind of like doing some mental math as I'm going. 7 times which one gets me close to 32? Well, I know 7 times 6 is 42. So I'm going to look at this one here. And I want to make it negative. So I do 7 times a negative 6, pick that one, equals a negative 42. When I add the other number to 42, negative 42 plus 10, what do I get? And that's a negative 32. And that's the b value that we were looking for. Okay, so my first kind of educated guess got me near where I needed to be, or actually where I needed to be. So 7 has to be multiplied by, well, the negative 6. So I'm going to put that negative 6 on this side. So minus 6 here, and then I'm going to put the plus 10, the other pair, here. And so now we have our final answer in factored form, 7x plus 10 times x minus 6. We're given this problem right here. 30n squared b minus 87nb plus 30b, and we want to factor this completely. Well, I notice in all parts I see the letter b, as well as I can pull a 3 out of each part here. So let's do that. If I pull out a 3b, what am I left with? I'm left with a 10n squared minus 29n plus 10. So now I have a quadratic inside the parentheses, and I'm really just going to think about that. Our a value, well, here is 10, and our c value is also 10. 10 can be a 1 times a 10, or a, well, 2 times a 5. Same thing here, 1 times a 10 and 2 times a 5. So our setup form is going to be 2 parentheses here when we factor, and we have one of these be the 1 and the 10 here, n, or 2 and 5, n. And same with the other one. Now one thing you should see is that the b value is negative. So the b value is negative and our c value is positive. That means both of these must be negative, because that's the only way you have two negatives multiplied, make it a positive 10, but then we're going to have them add to be a negative 29. So we can kind of test some values, and I'm kind of jump ahead here. Let's use 2 and 5. So we have 2n and a 5n here, and that's going to be our base. So we want to think, does 2 times one of these numbers times 5 times the other number get us close, well, to 29? And actually we see that with our negative 2 and negative 5 here. 2 and this pair here. 2 times a negative 2 is a negative 4. 5 times a negative 5 is a negative 25. If we add the two numbers together, we get a negative 29, and that's what we're looking at here. So let's make sure we set it up correctly. This 2n has to be multiplied by a negative 2 there. So I'm going to put the negative 2 on this side, because when we FOIL it, 2n will be multiplied by that negative 2. The negative 5 will go right here, because the negative 5 will multiply by this 5n. Combine them together, you get that negative 29n. And so we actually have this now in factored form. Our final answer is 3b times 2n minus 5 times 5n minus 2. We're given this problem right here. 9r squared minus 5r minus 10, and we have to factor this completely. First thing I'm looking at is, well, my a value, it's a 9. So two numbers that multiply to be 9 are either, well, let's say 9 and 1, or 1 and 9, and 3 and 3. Those are the two options there to kind of set this up. Because remember, when we're factoring it, it has to have, well, this form. Some 9r and 1r, and then some other number, or 3r and 3r. Something like that. And so you can see that's a 1. Our c value being a 10 or negative 10, okay, you can put a negative there if you need to. Two numbers that multiply to be 10 are just 1 and 10, and, well, 2 and 5. And we know, well, with our b value being negative and our c value being negative, one of these values must also be negative. Okay. So right off the bat, I'm looking at this, and we know what we have to do is say, one of these numbers times another one of the pairs, plus one of this one, the first value, times one of the other ones, add them together, can we get negative 5? Nothing really jumps out at me here, so I'm going to go kind of test all of them. But I'm going to be smart about testing all of them, okay? We know that our final result adding has to be negative. So in that, we want to make sure that the larger of the two being multiplied is going to be the negative on the right-hand side here. So what do I mean by that? Let's go test some values out. Well, if we have 9 times, let's say, one of the first ones, the larger one being 10, let's make that a negative 10, plus this one times that one. That ensures, by having the larger one of the two being negative, basically 9 times the 10 is going to be larger than 1 times the 1. I'll put a negative on the 10 there. When I add that, or multiply and add that together, I get a negative 89. That doesn't equal negative 5. So let's try another one. If we do, well, 9 times this one right here, plus 1 times this negative 10, we still have a larger of the two pairs there. The negative here will be larger. But testing that out, 9 times 1 plus 10 times negative 10 is a negative 1. That's not equal to negative 5. So let's try it again now, the first set, 9 and 1, with the 2 and 5. 9 times 5, and then we have plus 1 times 2. And the negative will go on the 5 because 9 times negative 5 is going to be a larger number than 1 times 2. Add that together, and that comes out to be a negative 43. And again, 9 equal to negative 5. Let's try it again. 9 times 2 plus 1 times 5. And we know 9 times 2 is going to be larger than 1 times 5, so let's put the negative on the 2 there. 9 times a negative 2 plus 1 times 5 is a negative 13. Still not our negative 5. Okay. So it's not, we've kind of tested all the options smartly with 9 and 1 being the first two values. Let's try the 3 and the 3. Well, 3 here times, let's go to the first ones here. So 3 times 1 plus 3 times 10. And since they're the same values, right, same a value really, we don't need to flip them around, but the larger one has to be negative, so it's this one here. 3 times 1 plus 3 times a negative 10. Well, 3 times negative 10 is negative 30, plus 3 is negative 27. Again, not equal to negative 5. Well, what about this one? 3 times 2 plus 3 times 5. And we put the negative on the 5 there, because that would be clearly larger. 3 times 2 times plus 3 times negative 5 is a negative 9. And we're still not at negative 5. So we've actually exhausted all the possibility combinations here, and, well, smartly, that could actually work that make it, well, with the negatives there, and nothing shows up. So what happens here? Well, this is not factorable. Meaning that this quadratic, the way it is, isn't factorable with our integers here. So our final answer is just not factorable. We're given this problem right here. 9p squared r plus 73pr plus 70r, and we want to factor this completely. One thing I noticed is that, well, there's an r in all three parts here. So if we pull that out, we're left with a 9p squared plus 73p plus 70. Okay, so now we have a quadratic in the parentheses, so let's just deal with that. Our a value, being 9, can be multiplied to be, well, 9 and 1, or 3 and 3. Our c value, 70. There's a good list here for them. 70 can be, well, 1 times 70, 2 times 35, and 5 times 14, and 7 times 10. And so now what I want to do is I want to set this up in a form when we factor it out. Okay? One of these numbers in the first one times one of the others, or the second column, so one of the a values times one of the b values of its factored form, plus one of the a times the other one of the c values, adds to be 73. And we're trying to make a good guess with this and anything that jumps out. And I'm always looking for things that get me close to 73. Well, I know a 9 times 7 is 63, so let's go deal with those. This first one and that last one here. 9 times 7 is equal to 63, so 9 times that's 7, 63. And then we have 1 times the 10 equals 10. We add them together, and we get, oh, this one here, and we get a 73. So by being smart with my guessing, I actually got my two pairs of numbers that work here. So we want to make sure we're writing this correctly or nicely. So let's put the 1 here first, and that's going to be a 1p. And then we'll have a 9p in the second part. 1 was multiplied by 10, meaning we have to put a 10 on this side here. And 9 got multiplied by the 7, so make sure 7's in the first parenthesis. And that's it. We actually have our answer in factored form. R times p plus 7 times 9p plus 10. And again, that's our final answer. We're given this problem right here. 9x squared plus 7x minus 56. And we want to factor this completely. My a value is 9, so we know 9 breaks down to be, well, a 9 times a 1, or a 3 times a 3. And our c value, 56. So it can be a 1 times a 56, 2 times a 28, 4 times a 14, or 7 times, well, an 8. Now we know it's a negative 56, and our b value is positive. So that tells us two things. One, that one of these numbers, one of the c values has to be negative. So one of these has to be negative. But the b value being positive tells us that when we take a pair from the a and we multiply it by a pair from the c, and then we add from the other one from the a and the other one from the c that be multiplied together, that together has to be a positive value. So I want to show you something here. We're going to go through every single possible option here, but smartly. We're not going to test all of them, but all the ones of the pairs of like matching 9, 1, and 1 and 56. See which one's the only one that could actually give us a positive answer. And those are the only ones we're going to write down and check. Because if we know it's going to give us a negative answer, we know it can't be a positive 7. So 9 times a 56 plus 1 times a 1. Well, we know we have to have the smaller of the two final values, like of the pairs, right? So 9 times 56 and 1 times 1. Which one of these is going to be smaller? And that's going to be the 1 times the 1. It's clearly smaller than 9 times 56. So I'm going to put that negative here on the 1, the second one. So 9 times 56 plus 1 times negative 1 is a positive 503. And that's clearly not equal to that b value 7. So we're going to try it again. This is 9 and 1 and 2 and 28. So 9 times 28 plus 1 times 2. Out of the 2 there, well, 1 times 2 is clearly 2 is clearly smaller than 9 times 28. Put a negative right there, and then, well, we can multiply it out. 9 times 28 plus 1 times negative 2 is a positive 250. Okay? Now, 9 times 14 and 1 and the 4. So 9 times the 14 and 1 and the 4, well, 1 times 4 is clearly the smaller of the two. I'm going to put a negative right there. Add that up. 9 times 14 plus 1 times negative 4 is a positive 122. Not 7. Let's do it again. 9 times 8 plus 1 times a negative 7. And what does that equal? Well, 9 times 8, well, sorry, I kind of went ahead of myself. 1 times 7 is clearly less than 9 times 8. 9 times 8 plus 1 times negative 7 is a 65 here. Now, of course, what I could also do is flip it around and do the 9 times the 1, and then 1 times 56, and then do the same process and kind of go through and see which one, of them being negative will clearly, well, I can show you the setup here. So, if we have 9, so keep going, 9 times the 1 plus 1 times the 56, okay? Well, clearly the 9 times the 1 is the less of the two values, right? Paired up. So I put a negative here, and then 9 times negative 1 plus 1 times a 56. What does that come out to be? Is that a 47? Positive 47. Again, not equal to 7. Well, to save time here, none of these pairs with 9 and 1 will work for any of these with one of them being negative. So let's go try the 3's, okay? And same idea, we're going to go through, say 3, and this one's a little easier because they're both 3, so we don't really have, we can test them all pretty quickly. 3 times a 1 plus 3 times 56. The smaller of the two is clearly 3 times 1, so we put a negative there. Excuse me, and 3 times negative 1 plus 3 times 56 is 165, not 7. 3 times 2 plus 3 times 28. Smaller of the two is a negative 2 there. And that comes out to be a 78. Again, not a positive 7. 3 times 4 plus 3 times 14. Okay? Well, 3 times 4 is clearly smaller. We multiply that out and we get a positive 30. Again, not 7. 3 times 7 plus 3 times 8. Again, 3 times 7 is smaller than 3 times 8. So we put it like that. And that comes out to be a positive 3. And again, doesn't fit 7 there. We don't have to do what we did here before of showing the option of flipping it around, of the kind of testing the other set of them, because, well, 3 and the a values are really the same here, so really wouldn't affect it there. And now we've kind of tested all of them, I didn't go through all the 9s for space reasons, but none of those would actually work. And so we again have all these options here that none of them actually factor neatly. So this one actually is also not factorable, meaning we can't factor this with any integer. So after all that, our final answer is not factorable. We're given this problem right here, 4x to the third plus 43x squared plus 30x, and we need to factor this completely. First thing I notice is that there's an extra x in each part here, so we can pull that out. Pulling that out, we have x times 4x squared plus 43x plus 30, and there we have it. Well, we now have a quadratic in the parentheses, and we can factor that. Our a value is 4, and 4 is either a combination of 1 times 4 or 2 times 2. Our c value is 30, and that can either be, well, 1 times 30, 2 times 15, 3 times 10, or 5 times 6. And what I'm looking at here is I want to take one of the pairs from A, multiply by one of the pairs from C, added to one of the pairs by A, added to one of the pairs by C. And we want to try to get our B value, which is 43. So instead of testing every possible one, I try to make an educated guess and try to get something that's close to 43. Well, 4 times 10 is going to be 40. That's pretty close. So let's go deal with these pairs here. This one and this one. So 4 times 10, well, that's equal to 40. Then the other pair would be 1 times a 3, and that's equal to 3. We add them together, and we actually get 43. So right off that first guess, we got it. We got a 43. We got our two pairs here. So how do we write this out? Well, x has to be here, and we still have to write it in a factored form. Let's put 1x here, and then this will be a 4x. Well, we said 4 had to be multiplied by the 10. So to do that, we have to put the 10 on this side. The 1 gets multiplied by a 3, and we put the 3 on that side. And now we actually have our answer in factored form. So here's our final answer. X times x plus 10 times 4x plus 3. We're given this problem right here. 10m squared plus 89m minus 9, and we want to factor this completely. We look at our a value being 10. The two numbers that multiply to be 10 are 1 and 10 and 2 and 5. Our c value is negative 9. Two numbers that multiply to be 9 are 1 and 9 and 3 and 3. And because our c value is negative, but our b value is positive, positive 89, we know only one of these pairs here, or values in the pairs, should be negative. So now I have to ask myself, what are the numbers from a pair of A times one of the pairs from C, plus the other one from A, and then times the other one from C gives us an 89. And remember, one of the C values has to be negative. So when I test this out, I try to test, make an educated test here, and think about, well, which ones multiply get me close to 89? That's a 10 times a 9, right? 10 times 9 is really close to 89, it's 90. So if we do 10 times positive 9, we get a positive 90. Then the other pairs would be 1 and the 1s. 1 times, and we said the other one had to be negative, so negative 1 here is a negative 1. We add the two together, and we get it. 90 plus a negative 1 is an 89. So making a smart guess, we got our pairs correctly. So how can we write this out? Well, we know it has to be in this some factored form. And our a value breaks down to be 1 and 10. So let's do 1m here and 10m here. Now 10 had to be multiplied by the 9, meaning we got to put the 9 on this side. So we have positive 9 there. And then that 1m gets multiplied by a negative 1 over here. And so there we have it. Our final factored form answer is m plus 9 times 10m minus 1. We're given this problem right here. For what values of b is the expression factorable? And we have the expression x squared plus bx plus 12. Well, we first want to start with our C value 12. What numbers, well, multiply to be 12? That's 1 and 2. Or sorry, not 2, 1 and 12. 2 and 6. And, well, 3 and 4. But other pairs that multiply to be a positive 12 could be a negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. So this list is actually important to find our b value, because we know when we factor, normally it'd be what two numbers multiply to be 12 but add to be a b value here. But we don't know what our b value is. But we know it could be, because we define all the possible values, we have the list of all the numbers that multiply to be 12. So we have to add every single one of these pairs. 1 plus 12 is 13, 2 plus 6 is 8, and 3 plus 4 is 7. Can't forget the negatives. Negative 1 plus negative 12 is a negative 13. Negative 2 plus negative 6 is a negative 8. And negative 3 plus negative 4 is a negative 7. And so actually here we have all of the possible b values for this expression. 13, 8, 7, negative 13, negative 8, and negative 7 are all possible b values that make this expression factorable, and that's our final answer. We're given this problem. Name 4 values of b which make the expression factorable. X squared minus 3x plus b. Tricky here, b is really our c value. Well, what do we know? We know we have to find a number that multiplies to be a b but adds to b the negative 3. Well, what about 0? What happens if b is 0? Well, what two numbers multiply to be, well, 0? Well, that could be a negative, 3 and a 0. Negative 3 times 0 is 0, but that adds to be a negative 3. So that works here. So 0 works for a b value. What about another one? Well, what about 2? 2 can be, well, any two numbers, what two numbers multiply to be 2? Well, negative 1 and a negative 2. Negative 1 times negative 2 is a positive 2, but we add them together and we get a negative 3. Negative 4. Negative 4, well, negative 4 times a positive 1 give me a negative 4. We add the two together, we get a negative 3. Negative 10. Negative 10 can be a negative 5 times a positive 2. Negative 5 plus 2 is a negative 3. And let's go one more, even though I said 4. Let's keep going on this gravy train. Negative 18. Negative 18 is a negative 6 times a positive 3. And we add those two values together and we get a negative 3. And actually, there's many answers here. All right, this is just some 4 of them, named 4 or 5 actually. So I would add 0 to negative 4, negative 10, and negative 18. But in reality, there are many answers. And I would be here forever if I tried naming them all. So here are, well, 5, broke good, not 4, but 5. 5 values for b which make this factorable, but again, you can have, there's many answers that work here. Here's just like the process for it. So that's our final answer. I hope the video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.